7. Find square roots.
Wait, no.
And compare real numbers. Alright. I'm going to mix up the colors today. I was like, are you already done?
I'm done.
Can I ask a question?
I mean, we only
Yes.
took like
So on this one,
an hour
it says
to
like,
record it.
okay, what percent of the seniors are planning to attend a two-year college are white? Should this be what percentage of the seniors planning to attend a two-year college?
Yes.
Are white? Okay. I was like, I wouldn't be stingy, but with this class, I gotta be careful.
Nope, it's a valid question.
Is that a cookie?
No.
Oh, shucks.
Not a cookie for a spelling mistake. This is an English
shucks.
class.
It still is a mistake.
It's not a math mistake.
That's not how you spell root.
What?
You spell root R-O-O-O-T.
Yeah, that's how you spell it, dude.
How do you spell root? Did you?
If b squared is equal to a, then b is a square root of a.
Do you know what time is here today?
I have no earthly idea.
I haven't seen it either.
So, for example, 3 squared is equal to 9, or negative 3 squared is equal to 9. So, 3 and negative 3 are square roots of 9.
Is that why negative numbers can't have a square root?
Sort of. But nothing squared is equal to a negative number. So that's
So
why.
wait. Negative number, same thing as a positive number when it comes to square root.
How did you
Sort of.
So would it be a negative?
Like if I told you, this is getting a little bit ahead, but if I told you that x squared is equal to 25,
Yeah.
to undo this, I would take the square root of both sides. X is equal to positive or negative 5.
So that's the same.
Yes. Because 5 squared is equal to 25, or negative 5 squared is equal to 25.
Because the thing, the negative number times a negative number is a positive. So
Yes.
I've been paying attention to behind.
Way to summarize it for us.
Oh.
All right. A definition.
Not again! Ew!
Perfect square is the square of an integer. Okay. An irrational number is a number that cannot be written as a quotient of two integers.
Why? Just why? You couldn't hold it for 2 more days until we get to the weekend? Or at least
An example of this is, or like examples of this would be square root of whole numbers that are not perfect squares.
If you want to have 2 in this class, I might just drop down to 1A.
All right, so the other day we talked about, we had whole numbers, and we said all whole numbers are also integers, and we said that all integers are also rational numbers.
How did you draw another box that good? You already supposed to.
But now I also have irrational numbers.
So he went. He kind of leaned down too. He's like.
All of these things, even irrational, are real numbers, not imaginary. So irrational numbers are in their own category. Okay?
He went. Stop.
Another thing we have in this section are conditional statements. Anybody know what a conditional statement is?
A statement that's conditional.
Anybody else?
Wait, what's the name
No,
of
I
this
don't.
channel? So I can go like run this back real quick. I'm gonna make a clip of both videos. Of him
Okay,
explaining
we are gonna focus. We're gonna focus. We don't need to be immature. I'm done. Conditional statements are written in if-then form. And consist of a hypothesis and conclusion. All right, so we're going to start with evaluating the expression. So number 4 is negative square root of 49. Is the square root of 49 a perfect square? What squared is 49? 7. This has a negative in front, so this is going to be negative 7. Six. Plus or minus the square root of 1. What's the square root of 1? 1. So we're going to keep that plus or minus, and we put 1. 8. Plus or minus the square root of 121. What would that one be? Plus or minus 11. How about 14? Negative square root of 1600.
What?
Any guesses?
Oh, 80. 80.
800.
Negative 80. 400. Negative 800.
You're closer.
Negative 400.
What'd you say?
4.
What'd you say, Drew?
Negative 400.
Nope.
Negative 40.
Yes.
I'm so smart.
Negative 40. Now, you know how I knew that? I don't just know that off the top of my head. You know how I knew that?
16.
The bone.
Huh? The square root of 16 is equal to 4. And the square root of 100 is equal to 10. So 4 times 10 is 40.
You're so smart. I wish I was smart.
Or 100 times 16 is 1600.
Could be, you should just grow a bunch of couples.
I should. I'm gonna do that for my kid.
Now, I would only expect you to know up to like probably 15 as far as like expecting you to be able to do this. I'm not going to like necessarily give you one of these on like the quiz, right? I'm going to give you something you would know because you don't get to use a calculator to do this.
Oh, you're gonna give us a quiz?
Oh my god.
Do
Where
we
have
not
you
just
been?
have like a 10?
Yes, you're going to take your quiz on Wednesday.
Where have
Oh,
you
yeah.
been?
Don't we have a game Thursday too?
Y'all do, yes.
Is it home game?
JV only. Because I'm coaching you that day.
You will. Oh no, that's not. Wait, is it a home game?
No, it's away.
Wait, the Oak Tree one?
You're coaching them? I'm scared.
All right. These were all perfect squares, correct?
Yeah.
So what do we do if it's not a perfect square?
Make it a triplet.
And you don't have a calculator?
Make it a triplet.
Exactly.
I would approximate what I think it's going to be.
Don't do it.
Don't do it.
So we're going to approximate square roots now. So I'm going to find a square root that it's close to and say that it's probably about that value. Okay? So if I have something like 16, it is negative square root of 18. So what perfect squares do I know on either side of 18?
4 and 5.
Okay, so I know 16 and I know 25, right? So is 18 closer to 16 or closer to 25? 16. So what's the square root of 16? 4. So this is going to be, we use the little approximate symbol, which is a curly equal sign. And we're going to say that this is approximately negative 4. The square root of 150. Well, what do we know on either side of 150?
12 and 13.
12 and 13, so we know 144 and 169. Which one is 150 closer to? 144, so this is going to be equal to 12. Or I guess I should say approximately.
I don't know. I haven't checked any of my grades before this year.
My mom's coaching. You know how to do that?
I hate grading,
My
bro.
mom be like, give me the phone.
Let's see. One more. 22. Negative square root of 65. What do you think this one's approximately?
Ooh. 5 and 6.
Doesn't that mean
5 squared's 25 and 6 squared's 36, so I don't think so.
My bad. Oh, 8. I had 8 and I 8 until I was sick on.
So 8 squared is what?
That's what my 5th grade.
64. So it's obviously only one away, so we don't even really need to look at the other one. So this would be negative 8. All right, as part of the first half of the chapter that was on your quiz you took the other day, you had to take the numbers and you had to say if they were whole, integer, or rational, and then you had to put them in order from least to greatest, right?
Oh no.
Now we're going to do that with square roots, and we're going to have irrational numbers. Okay? That's a number that keeps going forever and ever.
like pi?
Yes. Pi is an irrational number.
So last year we just did pi as 3.4.
Well, yeah, that's like the short version if you're going to multiply it. You're not going to write 3.141592653589793238462. Like, you're not going to write them all out.
Yeah, that's because you're gonna end up with a poster 10 times bigger than that.
Bigger than that. Goes on forever.
Oh, okay. What do you divide to make that
Do
number?
you just keep adding numbers? Is that
Hmm?
What do you divide to make that number?
I'm glad you asked. You'll find out on
Does
March
circumference
14th.
have a circle?
March 14th?
Oh, that's pi day?
I will read you a book all about where it came
Yeah!
from.
Instead of doing work, we get to read a book.
Oh, look, on Pi Day, we party. We don't do any math, we just party.
Wait, what?
Oh my gosh, I'm so
March
excited.
14th.
Can I wear that day?
But isn't that like 5 to 10 months from now?
You gotta paint on your pie shirt.
6 months from now.
Because you painted on it.
Almost
I
exactly.
don't want to say 6, 7.
That's what I said.
Okay.
Pie shirt.
24. The square root of 49. 8. Negative square root of 4. And negative 3. What I would do is I would take all of these numbers and I would try to figure out what they are equal to as far as like a whole number or an approximation of a whole number. Okay? Do I know what the square root of 49 is? This is 8. The square root of negative square root of 4 is negative 2. And then I've got negative 3.
So it'd be negative 3, negative 2, 7, 8, and the two ones would be IR, and the other ones would be WIR. The two negatives
Yep.
would be IR, and the other two would be WIR.
Integer, rational, WIR on these ones. Okay, now, integer and irrational both start with the same letter, right? So when I'm doing irrational, I'm going to go back up here for a second. I would abbreviate this as IR. I usually do a big I, little r. Okay, for irrational. Especially because I have integer and I have rational. That's why I do a big letter, little letter, so it's not confusing. Okay, if you want to write the words out, that's fine. I like to shorten it as much as possible. How about...
Do we have to like rewrite it with the actual square root and stuff?
This is fine. Let's do 28. Negative 8 over 3. Negative root 5. 2.6. Negative 1.5. And the square root of 5. So I would say let's try to get everything like as a decimal or some like rough approximation of it. So what is negative 8 divided by 3 as like a decimal or something close to it? Or you could even probably do a mixed number and still be able to see what it is.
2.6 something.
So this would be the same as basically 2 2/3. 2/3 as a decimal is 0.6 repeating. So this would be negative 2.6 repeating. How about the negative square root of 5?
2.5.
Not going to be 2.5. It's going to be a little bigger than 2, right? Because the square root of 4 is 2. So I would just say something like negative 2 point, and then just leave it like, I don't know, put like a little thing there so that you know. I can tell you it's less, or it's, yeah, it's not as big as 2.5 though. All right, and then I've got 2.6, I've got negative 1.5, and then over here I've got 2 point something, right? And I don't know exactly what it is. So now I need to write these in order. How would I do that?
2.6, negative 2.6, negative 2, negative 1.5, the 2 point, 8, and then 2.6. Actually, I don't know, because that could be either way. Either direction.
So if the number was closer to 9, like if it was the square root of 8, it probably would be on the other side of 2.6, okay? But if it's just the square root of 5, that means it's just a little bit bigger than the square root of 4, which we know is 2, okay?
So, the 2 point, comes for 2.6. Oh yeah, you already did that. Okay.
Yeah, I just wrote it as a square root. All right, so I need to classify my numbers. So repeating numbers are rational, right? Or wait, this is just 2.6. Or is this? Yeah, this is rational, right?
Yeah, next one's on.
Are you sure?
I think.
What did I say the square root of non-perfect squares is? Irrational. So this is going to be an I with a little r.
Isn't it 2.6 repeating?
Oh wait, is this? Hold on. Oh, I looked at this one. Well, yes, but it's still going to be rational. A repeating decimal is still rational. But if you want me to put the line over it, I can. All right, what's negative 1.5?
I and then R.
Yep, so I didn't have any whole numbers or integers on this one, right? All right. Rewrite the conditional statement in if-then form. Tell whether the statement is true or false. If it's false, give a counterexample. This is like an intro to geometry. 30. All whole numbers are real numbers.
That's true.
Well, we got to write it in if-then form.
If all whole numbers, if real numbers.
No.
If a number is
If a number
real number.
is a whole number, then it is a real number. Now, is that true?
Yes.
So we would write true. Let's see, 32. No perfect squares are whole numbers. We have to write it as an if-then statement. We're not saying if that's true or false, we're saying if our if-then statement is true or false.
If the perfect squares are,
If a number is a perfect square, then it is a whole number.
then it's
And
not
then it
a
is
whole
not a
number.
whole number.
And that would also be true.
No.
Yeah, it would.
If a number
Oh, gosh.
is a perfect square,
Perfect whole number.
then it is not a whole number.
No, it's not. A perfect square is a whole number. That's the whole thing about it.
So this statement is false. Okay, because perfect squares are whole numbers. So a counterexample to this would be that we could say as like,
40, the square root of 49.
Sure, the square root of 49 is equal to 7 or negative 7.
I thought it could be the same.
Negative 7 squared is 49 and 7 squared is 49.
Okay. How'd you get 3W?
All right. 34. Evaluate the expression for the given value of x. 3 plus the square root of x when x is equal to 9. So I'm going to replace x with 9. So I've got 3 plus the square root of 9. What's the square root of 9?
3.
So I've got 3 plus 3, which is 6. (38) Negative 3 times the square root of x minus 7 when x is equal to 121.
So that
Plug in 121, so I've got negative 3 times the square root of 121.
the answer is negative 40.
So the square root of 121 is,
11.
I've got negative 3 times 11.
Negative 33 minus 11 equals negative 45.
Negative 33 minus 7, negative 40. All right, any questions, comments, or concerns?
Comments or concerns?
That's what I said. Let's go 3 through 39, every other odd.